At the very heart of everything we see, everything we are, there lies a profound mystery. It's like a cosmic crime scene, billions of years old, and the only piece of evidence we have is everything, the entire universe. And the biggest question of all is, where did it come from?
It's really the ultimate question, isn't it? The one we've all wondered about. What was there before the beginning? I mean, what lit the fuse that started the Big Bang in the first place?
Now, you might think the Big Bang is the answer, but for physicists, it's actually where the story goes cold. All our most trusted laws of physics, especially general relativity, our theory of gravity, they just stop working. They completely break down at that very first moment. So, to solve this cosmic mystery, we first have to investigate a huge fundamental flaw in the traditional story of creation. It's something called the singularity problem. Okay, so the main suspect here is the Big Bang singularity. It's a concept that forces you to picture all the matter and energy of the entire known universe, all of it, squeezed into a single point of infinite density and infinite heat. It's basically a mathematical and physical dead end, a place where our rules just don't apply. Think of the classical universe kind of like this cone. Time flows upwards, and as it does, the universe expands. The cone gets wider. But if you trace it all the way back, what do you get? You hit that sharp, pointy tip at the bottom. That's the singularity. It's a hard boundary, a literal edge to space-time itself. And that sharp beginning, that's a huge problem. This classical view means you need some kind of unknown initial conditions, some outside push to get the whole thing started. But the goal of physics really is to find a description of a universe that's totally self-contained, one without those sharp edges, one that doesn't need an external kickstart, and one where the laws of physics work everywhere. So if our classical physics is failing us right at the start, where do we look next? Well, we turn to the strangest, most successful, and honestly most counterintuitive theory we've ever come up with, quantum mechanics. This is our crucial clue. Let's look at the famous double-slit experiment. Imagine you fire a single particle, let's say an electron, at a screen with two little slits in it. Logically, you'd expect it to go through one slit or the other, leaving two simple bands on the detector screen behind it. Makes sense, right? But that is not what happens. Instead, we see this weird interference pattern, a whole series of bands. The only way that's possible is if the particle somehow went through both slits at the same time and interfered with itself. And this is where it gets really mind-bending. According to general relativity, matter and energy are what curve spacetime. So, if a single particle can be in two places at once, its gravity must be curving spacetime in two different ways at once. This leads to an absolutely staggering conclusion. We don't just have a superposition of particles, we have a superposition of entire spacetimes. So here's the key takeaway. Quantum mechanics tells us that to figure out the probability of a particle getting from point A to point B, you have to add up all of its possible paths. So if we want to understand the universe, we have to do the exact same thing, just on a cosmic scale. We have to sum over all the possible histories, all the possible universes that could connect the very beginning to where we are today. This whole quantum approach of summing over all possible histories, it leads to a radical and, honestly, a really beautiful solution. It's one that completely rewrites the story of creation by, well, getting rid of the beginning entirely. Back in the 1980s, two physicists, James Hartle and the great Stephen Hawking, came up with this revolutionary idea. It's often called the no-boundary proposal, and their suggestion was as profound as it was simple. What if there just wasn't a beginning to begin with? This gives us a totally new picture of the universe. Instead of that sharp, problematic cone, it's more like the bottom of a shuttlecock. It's smooth, it's rounded. There's no point, no edge, no boundary where time suddenly kicks off. The past is finite, sure, but it's seamless. And that's the core of the no-boundary proposal. The universe is completely self-contained. It doesn't need a creator or some external cause to get it going because there's no getting going moment to explain in the first place. The whole singularity problem, it just vanishes. But wait, if there's no beginning, how did it, get here? The answer comes from another wonderfully bizarre concept that's right at the heart of quantum physics. When you dig into the math behind the no-boundary proposal, it looks uncannily similar to a well-known quantum phenomenon called, fittingly enough, quantum tunneling. So, what is quantum tunneling?
It's this wild idea that a particle can spontaneously appear on the other side of an energy barrier it shouldn't have enough energy to cross. Imagine trying to roll a ball up a hill, but you don't give it enough of a push. Classically, it'll just roll back down. But in the quantum world, there's a chance it'll just appear on the other side anyway. It's a jump from a forbidden state to an allowed one. And this proposal suggests our entire universe might have done the exact same thing. So, what did the universe tunnel from? This is where we get the most incredible statement of all. This isn't tunneling from empty space. No, this is a quantum leap from a state where space, time, and matter literally do not exist. It's describing the spontaneous creation of reality itself, out of nothing. Now, this idea is so elegant, and it solves that pesky singularity problem. But like any good mystery, cracking one case just opens up a bunch of new ones. Because this is a quantum theory, it doesn't just give us one single definite history of the universe. Instead, it provides what's called a wave function of the universe. Think of it like a weather forecast that doesn't just predict sun, but gives, say, a 70% chance of sun, a 20% chance of clouds, and a 10% chance of rain. This wave function calculates the probabilities for all the different kinds of universes that could have possibly tunneled into existence. And this leaves cosmologists with some really deep, unanswered questions. For instance, how can you even talk about the probability of a universe when we only have one example to look at, our own? And maybe the most important question of all, does this theory predict that a universe like ours, one with stars, galaxies, and life, is a likely outcome? Or are we just an unbelievable long shot? Which brings us to a final, really profound thought. This theory suggests that our entire reality is just one possibility that made the quantum leap from non-existence into being. It really makes you wonder, if our universe could just tunnel out of nothing, how many other potential universes are still waiting there, in that realm of pure possibility?